everyone. Today we are diving into the world of container orchestration on AWS, specifically comparing two powerful services, AWS ECS and AWS EKS. If you're wondering when to use ECS versus EKS for your microservices or how they differ in complexity, control, and scalability, this video is for you. Let's get started. Before we jump into the differences, let me explain how incoming requests flow in this architecture. All client requests, whether from web, mobile apps, or APIs, first hit a single application load balancer or ALB. This ALB acts as the entry point to our microservices platform, routing traffic intelligently based on the type of service and its requirements. The ALB routes the request either to AWS ECS or AWS EKS. This routing decision is driven by the complexity and scalability needs of the service. Here's the deployment environment strategy we followed. Simpler, stateless microservices that have predictable workloads and fewer complex networking needs are deployed on ECS, Fargate. Whereas complex, scalable, and asynchronous services, those that require advanced orchestration features, run on EKS, Kubernetes. Now let's talk about AWS ECS or Elastic Container Service. ECS is a container orchestration service that makes it easy to run and manage Docker containers at scale. For example, services like our user service built with Spring Boot and payment service built with Node.js ran on ECS. So, why choose ECS? Here are the key reasons. ECS is easier to set up and manage, especially for smaller teams. It integrates tightly with other AWS services like Application Load Balancer or ALB, IAM roles, and CloudWatch for monitoring. Deployment cycles are fast, ideal for smaller containerized apps. We leveraged Fargate mode, which means serverless containers, no need to manage the underlying servers, and it provides automatic scaling. In practice, here's what the ECS deployment looked like. We built Docker images for each microservice and pushed them into Amazon ECR, which is AWS's container registry. ECS tasks were launched on Fargate using task definitions that specified CPU, memory, and networking requirements. The ALB routed traffic to the ECS task, handling incoming requests and load balancing across instances. Next, let's Next, let's move on to AWS EKS or Elastic Kubernetes Service. This is a fully managed Kubernetes service from AWS, and we need it for more complex and scalable workloads that required advanced orchestration features. EKS offers a lot of powerful features. AWS manages the full Kubernetes control plane, giving us flexibility for custom networking and deploying service measures like Istio. It supports advanced deployment strategies like canary releases and blue-green deployments. It's much easier to integrate with Kubernetes ecosystem tools, for example, Helm charts for managing deployments, Prometheus and Grafana for monitoring. EKS was our choice when microservices had high scalability demands or complex stateful workloads. Plus, if you need fine-grained resource control and custom configurations, EKS has you covered. Here's what the EKS deployments look like. Kubernetes clusters were provisioned using EKS. Services were deployed using Helm charts, which simplify app packaging and deployment. We used Kubernetes Horizontal Pod Autoscaler or HPA to scale pods based on CPU, memory, or custom metrics. For monitoring and logging, we integrated Prometheus and Grafana directly into our clusters. To wrap it up, here's a quick comparison between ECS and EKS based on our experience. So basically, ECS is great for smaller, simpler workloads and teams that want quick setup and native AWS integration. But when your app needs advanced orchestration, scalability, and flexibility, EKS is a better choice if you have the Kubernetes expertise to manage it. I hope this helped clarify the differences between EWS, ECS, and EKS and gave you a better idea of how incoming requests flow through the ALV and are routed based on service needs. If you found this video useful, please hit that like button and subscribe for more cloud and software engineering content. Also, drop your questions or topics you want covered in the comments below. Thanks for watching and see you in the next video.